Since 1961, about 400 humans have ventured into space. For the rest of the 5 billion of us back on Earth, we rely on the pictures and first-hand accounts of the astronauts to share their experience. The pictures have gotten clearer over the years, but the onset of high-definition technology opens a brand new window for the world to witness the wonders of space exploration. Now, for the first time ever, NASA's attempting the first live transmission from space in high definition, and Discovery is here to bring this exclusive event to you. Right now, the 3-man crew on the International Space Station is preparing for this momentous occasion. So pull up a chair and get ready, as we now prepare to link up live with the space station in HD. We're here in Discovery's own state-of-the-art broadcast center, awaiting the first ever live downlink from space in high definition. Hello, I'm Robert Hager. The space station project began in 1998. It's been manned continuously for the last 5 years. Construction is still underway, and it's scheduled to take another 4 years. Currently, on board the space station is an international crew of 3. Thomas Reiter of the European Space Agency, Mikhail Turin of Russia, and Mike Lopez-Alegria from NASA. Reiter will serve as our space cameraman today, and Lopez-Alegria, or Mike, will be our host. But before we connect live to the astronauts on station, let's get a quick background update on ISS.
Liftoff of Space Shuttle Atlantis.
With the shuttle program back to what NASA calls its normal operational tempo, assembly of the International Space Station is now scheduled to be completed by 2010. Assembly of ISS began in 1998 when the first 2 modules were joined in orbit. And the station's been continuously manned since November of 2000.
We've had crews permanently on board Space Station for about 5 years, and that's a different way of doing business. We're not just going into space temporarily, we're going into space to stay.
A multinational effort, Space Station is the largest collaborative scientific project in history. The construction and operation of a permanently manned orbiting space station is seen by many as a critical leap forward in advancing space exploration. Assembled in orbit, ISS will eventually cover an area as large as a football field. Research in the station's labs has led to scientific breakthroughs that benefit all of humankind.
One interesting thing we're doing on Space Station is we're looking at how drugs and vitamins are absorbed in zero-G and how that differs from the way they're absorbed on the ground.
The Orbiting Science Laboratory also serves as a learning environment for future space travel.
I think in a nutshell, without an ISS, we don't know the right questions to ask for long trips in space and in deep space. Now, while ISS is not deep space, it is a frontier where people can live in space long enough to ask the right questions, to collect the right data. We're doing that now.
Currently living on board Space Station is the 3-person Expedition 14 crew, representing Russia, Germany, and the USA. The crew will conduct many experiments relating to spacecraft systems, Earth observation, and human life science. As with the previous missions, this team's multiple-month stay on station will also serve as a dress rehearsal for upcoming long-duration spaceflight missions.
I think the greatest thing ISS can do is really be that permanent beachhead in space that teaches us how to go beyond. It's the Canary Islands to the Columbus trips and the Magellan trips. It's how do we react to space? What do we need to eat? How should we work? And so a space station is a right step.
Living and working in space, the space station mission continues to help improve life here on Earth, as well as pave the way for journeys farther into the cosmos. Well, there's no doubt that going into space is risky and important work, but it must also be the experience of a lifetime for any brave astronaut who has the chance to go. Being able to share this experience with folks on Earth happens through pictures and personal accounts from the astronauts. The ability to show HD quality pictures from space brings this experience to an even higher level. And having a veteran shuttle astronaut like Pierre Thuot to describe this experience is sort of the icing on the cake. Pierre, welcome.
Thanks, Bob. Great to be here.
Now, tell us about, we're going to see these beautiful, clear pictures. What are you looking forward to in the next half hour here?
Well, I'm sure many of the viewers have seen HD professional football and the clarity and definition there, but heretofore we've only seen standard definition images from space, so you don't get to see the clarity, the resolution of what's going on. And I think just like in a football game, there's a lot of action. There's going to be a lot of action today, and the floating, which is the most fun about being in space. You're going to get to see that in great definition.
So the space station itself up there, 215 miles in space, what's the primary benefit of that for us, do you think?
Well, I think the basic benefit is that it's a research laboratory. We can do things in space that we can't do here on the Earth. You can change pressure and temperature here on the Earth, but you can't change gravity. And so when we do experiments in space and alter gravity, we're able to find things out about materials and medicines and things like that we can't find out here on Earth. So hopefully, 24/7 laboratory, we'll be able to find some new drugs, some new materials and things that we can use here on Earth.
Now, the long-range goal at the moment is to go on, try to go back to the moon, and then jump from there to Mars or even further out, decades from now. But what can we learn that would be valuable for that from the space station itself?
Well, the crews spend about 6 months in space, and if you go to Mars, you're going to take a year, maybe a year and a half. So we need to really understand the human physiology, what happens when people are in zero gravity for that long a time, and also how they're going to be able to walk on Mars when they get there after they've been, say, a year in space. So they're doing lots of experiments on human physiology and trying to understand that, so when we do go to Mars, the astronauts will be able to function.
Pierre, thanks very much. In anticipation of the big event, there's a quick intro to just how amazing pictures from space in high def can be. If you're afraid of heights, hold on. NASA's hoping the brilliant high-definition TV images now being shot on board the International Space Station might make you feel as though you're actually there.
Space is real, and we live in space. So capturing that through high definition brings us closer to being there. And that's an important element of space exploration.
The human eye is a pretty amazing device, and it can see lots of fine detail and fine color structure. HD gets us closer to what you can see with your eye.
One of NASA's main missions has always been to share information about space exploration with the public. From the first manned flights in 1961 to the present day, just over 400 people have been lucky enough to blast into orbit and see for themselves the spectacular panorama of space. The rest of us have had to rely on video technology, and this often made for some fuzzy viewing. Now, with high-definition TV, the days of grainy images transmitted from space are ancient history.
The first HDTV camera that was flown in space was flown on STS-95. It was the John Glenn mission. And I do remember it very vividly. Everybody in the room, it was almost electric for them watching this video, because all of us have been involved with NASA video for literally decades, and it was nothing that we had ever seen before. It was just incredible.
But it's not just about pretty pictures for the viewing public. NASA hopes the sharper images will also help researchers on the ground learn more about our home planet.
If you look at like a sunrise or a sunset, and you can see how thin the atmosphere really is, you know, that little thin blue atmosphere is what keeps us alive here on the Earth. I think you get an appreciation of how fragile our planet really is.
For Earth sciences, it does a couple of things. It allows us to get a moving image, what they do in orbit of the Earth, to get things in better perspective than you might get with still images.
High-definition TV can play an important role in understanding and documenting onboard experiments as well.
It's accurate enough that we can actually use it for measurement purposes, which you can't do with analog video. There's too many inaccuracies in analog video.
High-definition TV has invaded the Earth, the space station, and beyond.
We're now in the HD era here on Earth. Television, movies, and all that. We are really also moving into the HD arena in space for the public. Not only at Mars, not only at space station, but also at the moon. In 2008, we're launching the Lunar Reconnaissance Orbiter, which will carry a powerful set of imaging tools, which will produce basically HD imaging of the moon at scales that we'll be able to see ourselves, the leftover hardware of Apollo. We're in an HD age, and it's going to the planets.
So until the day comes when we can all take a rocket ride into orbit, sit back and enjoy the amazing HD TV views from above. And we think our signal is through now. It looks like the crew is ready. Commander Mike Lopez-Alegria is standing by in the Destiny Laboratory aboard the International Space Station to bring us the first ever live downlink from space in HD. Mike, can you hear me out there?
I hear you loud and clear, Robert. How do you hear me?
Okay, I hear you very well, and we'll explain to our viewing audience that because the distances involved here, they're 215 miles away, so there's just a little delay in the back and forth. Mike, show us what you can. You're in the Destiny Laboratory there, right? Can you take us on a little tour of what it looks like?
You bet. This is actually the Unity node, which is attached to the Destiny Laboratory. We'll be going there in just a second. But this is one of about 6 habitable volumes that we have on board the space station. My crew of 3, Thomas Reiter from the European Space Agency, who is behind the camera, so you can't see him, and Mikhail Turin, a cosmonaut from the Russian Space Agency. And I have been aboard for about 2 months or so. Actually, Thomas has been here a bit longer. And we basically spend most of our time doing experiments, operating, maintaining, and constructing it sometimes this space station. So let me start with a little bit of a tour. As I said, this is a node. It has 6 different ports to which other modules can be attached. We also use it mostly for storage. Here you see a couple of spacesuits that we use for EVAs, extravehicular activities, or spacewalks. This is a Russian version on your left and a US version on the right. And this is what we affectionately call the water wall. There are a whole bunch of these collapsible water containers behind them, which you see right here. Water, of course, is very precious to us, as it is to everybody on the ground. We use it not only for food and cooking, drinking, and hygiene, but we also use it to generate oxygen. So as you can see, it's sort of a very important consumable for us. And then above me, on what would be the ceiling, is our resistive exercise device, which is also sort of like a universal weight machine. And we use this as one of our exercise tools to keep us in good shape. I'll see if I can demonstrate here one of the exercises we might want to do. Of course, the loss of bone and muscle density in space is a very important consideration, so we have a couple of countermeasures we use to try to avoid that loss. See if I can do a couple bench press repetitions here. The resistance, of course, we can adjust with these cans, which basically it's just a great big rubber band that keeps the resistance wherever we need it. Actually very effective. Okay, we're going to head forward now from the Unity into the laboratory module. As you mentioned, the lab module is called Destiny. And this is where we do the bulk of our work here on the US segment. We have a number of experiments that are going on in here all the time. We do some operations from here, and I actually live here right now. Tomas and Misha live in the Russian segment in the service module. First stop here is our robotic workstation. We use this to control the space station's robotic manipulator system, otherwise known as the robot arm. You can see a couple of hand controllers, some monitors that we use to view our work as it's going on. Continuing forward, you see we have a lot of these laptops deployed. We actually control the station largely through laptops when we do it on board, although our team in Mission Control in Houston does most of that commanding. Here are a couple of experiments. One in particular is pretty interesting. This European delivered MELFI, which stands for minus 80 degree laboratory freezer. It's in fact closer to minus 100 degrees right now, and I thought I might show you where we like to keep our ice cream if we had any on board.
Mike, that's a new piece of equipment up there, right?
Mike, that's a new piece of equipment up there, right?
Yes, MELFI came up about 2 shuttle flights ago, and we're already using it to store samples of blood and urine that we're collecting for some experiments as well as some others. I'll give you a peek inside here. In case you can't tell on high definition, which I'm sure you can, it's quite cold.
How cold again was it, Mike?
In fact, it's frozen, it appears.
How cold again was it, Mike?
It's about a minus 100 degrees centigrade. So it's quite cold.
Yeah, I would not want to go out in that. But the fact that you got that freezer up there now enables you to store samples of your own blood for blood checks later, right? For determining bodily changes as you stay on the space station over a longer time?
Right. One of the things that we're very interested in, of course, is what happens to the human body as we are subjected to long periods of microgravity. And we can measure what we intake by basically notating everything that we eat or drink in a certain period. And then our blood samples correlate how our body is processing those. And of course, the blood samples we can't analyze on board, so we freeze them for later analysis on the ground.
How about the rest of the experiments?
Okay, right above me now is the European Modular Cultivation System. It's basically a couple of large centrifuge tables which can hold some biological samples, either plants or other tissues, that we can vary the effects of gravity by spinning them at various rates. There's all kinds of photographic and other recording equipment inside that can monitor what's going on with those samples as we use them. Immediately to your left is one of our 2 human research facility racks. There's equipment to measure gas intake. We use that a lot when we're doing exercise to try to understand how our bodies are processing, metabolizing oxygen, especially on board. I'm passing over one of our favorite spots in the laboratory, which is the window, which looks down over the Earth. We'll probably take a look at that a bit later.
Oh, you bet. We're planning on that.
Your left, again, is the CVIS, the cycle ergometer vibration isolation system. You see it appears to be floating. It's actually on a series of vibration isolators, so that our loads that we put in when we're pedaling don't get transmitted to the structure and disturb the microgravity environment aboard the station. On the left, on your right, behind that other laptop is a microgravity science glove box that we can use. We would put our arms inside those 2, well, you can only see one of them, green circles there, to be able to work in an environment that might be hazardous to us, or in other way want to be protected from aboard. This is a very forwardmost part of the node. All this gear that you see here is stuff that has been pre-packed. It will be going home on the shuttle Discovery, which we expect in early December. And a couple of more experiments. This is called Altea, the anomalous long-term effects on astronauts. This is basically a measurement tool to measure, I'll just call them cosmic rays, that we take on board. We actually put this EEG cap on and put our head inside this device, and we can correlate. Actually, there's some visual disturbances that occur, and we can correlate when they occur to when these sensitive sensors can measure impacts from cosmic energy. Lastly, this experiment is called Spheres, synchronized position hold. Let's see if I can get the rest of the acronym. I can't. Anyway, it is pretty neat. It's a satellite system. We have a couple of them, actually, and is one of our, in fact, I think it's the only DoD experiment we have aboard, but it uses CO2 gas to maneuver itself, and we can actually get these 2 satellites to fly in formation with each other and actually dock to each other. So that's a pretty fun experiment. We got to do that a little bit last weekend.
And I think I see the idea there that you couldn't do that.
Anyway, that's kind of a very rough overview.
Couldn't do it on Earth where there's gravity. You need to be in space. Are we able to move over to the window? Are you? Can Thomas move the camera over there and show us the view out?
Sure, you bet. He's showing you our laptop right now, which shows you where we are. Obviously, we are just crossed over the west coast of Africa after having passed through the North Atlantic. And he will now take the camera down into the lab window and show you exactly what it looks like from here. The terrain below, how would I say it? It is an experience that makes you really appreciate what we have down there, that it's fragile, that we need to protect it, and you feel very detached from it, and sort of you miss it. It's your home, it's where all your loved ones are, where all of your experiences have happened, and you really get a sense of being separated from it in a way.
Now, I think in terms of the imagery and experiments, people sometimes wonder, I mean, we have unmanned satellites that circle the Earth and take this kind of photography, but there's some advantage too to what you can do, right? With a human looking out there to where to focus in, where to take the shots?
Looking out there, where to focus in, where to take the shots?
Well, certainly the advantage that humans have over robots is that we can adapt quickly. We can, respond to changing situations. For instance, my predecessor as science officer aboard on Expedition 13, Jeff Williams, managed to take a picture of a volcano that was erupting in the Aleutian Island chain, and even if they wanted to program a satellite to take a picture of it, nobody could know when it was going to happen or when the satellite would be there. It would take a while to get there. It was a very short eruption, and he managed to take a shot of it. So, yes, we do have the ability to respond in more real time. And I think we also have a different sense of, art in a way. We can take pictures that a satellite might not want to take because from a science standpoint, it might not be all that interesting, but we are all humans after all, and the pictures actually appeal to a different sense than
Mike,
just
let's
the science.
go to the food now. I think this is the fun stuff for viewers, I think. Can you show us how you manage up there? I mean, I can only imagine that it's very, very difficult in space where juices and things like that want to float all over the cabin, crumbs. But how do you deal? Just give us a little lesson in it.
How do you deal? Just give us a little lesson in it.
Well, you're right. I mean, it's different. It's some of it's challenging, some of it's fun. I've prepared a couple of items for your consideration. First of all, our food comes in a variety of different forms. Some of it is dehydrated, and some of it is thermal stabilized. Some of it comes in its natural form. This is soup before it's dehydrated. It doesn't look particularly appetizing. And this is soup. It's noodle soup with meat after it's been hydrated. It looks a little bit better. You can choose to eat this soup with a spoon if you'd like, but it's more practical just to use this sort of built-in straw device.
That all looks so difficult, and I know studies have shown that eating is very psychologically important for crews on space stations where they're away from the Earth for a long time. Are you able to get some pleasure out of eating, even though it's a lot more difficult than on Earth?
Absolutely. Well, first of all, you're right. Eating is extremely important, and it's the folks at NASA and the Russian Space Agency go to great lengths to try to, accommodate our tastes and our what we think we're going to like on orbit. Of course, people's tastes tend to change. We tend to like things that are a bit more spicy. You can imagine that salt and pepper don't work so well up here, so we actually have our salt, pepper, soy sauce, and actually some wasabi in a different sort of a form. This is actually salt, and in order to apply it, you just remove the lid and squirt some. You can see some of it is caked on the outside, but you just sort of squirt some onto whatever your food is.
I got the idea there. If you were shaking it like a salt and pepper shaker, it'd go all over the laboratory, right? The crumbs, the salt and the pepper.
Yeah. Yes, the salt granules would definitely be problematic. Of course, these candy-coated almonds are a real treat. They taste about the same, but they're obviously a lot more fun. If you'd like, you could perhaps try one.
In high definition, that's something coming at us like that.
In high definition, that's something coming at us like that.
And then drinking, of course, this is what tea might look like, or what it does look like, before it's been hydrated. This is tea with sugar, so you can see the tea bag inside along with the sugar. And then once you hydrate it, we put about 200 milliliters or so of water in there, and it actually tastes quite good. Same idea in this is orange pineapple drink, and of course you got to be careful. I would be remiss if I didn't do the obligatory orange bubble trick.
Nice.
Nice.
Fluids in space end up taking the form of spheres to reduce the, or due to surface tension, and you can sort of play with it as much as you want. You can blow on it to get it to do certain things, but the best thing to do with it is to eat it or drink it.
So simple. That looks great.
We have some.
So simple, that looks great.
We have some fajitas on board that we could use. These are actually, obviously, in its natural form, tortillas. So we would just take the tortillas and then take the fajitas, which I'll show you a shot of inside. Pretty appetizing. We have chicken fajitas, beef fajitas. There are probably over 200 different menu selection items, and we build our own menus. We eat each other's food. This one has a red dot on it. That means it's mine, but it doesn't matter. We eat each other's food, and we build a menu that supposedly goes by days.
So you're
but
living
basically,
pretty well
when
up
it's time
there.
to eat, you just look in the pantry, take out what looks good, and eat it. We do okay up here.
Mike, I think we're out of time, but I want to thank you a whole lot for taking time out of your incredibly busy work schedule to share a very special technology first with our viewers. Seeing you live in HD TV, I mean, seeing the pictures from here on Earth, it's really like being there. So thanks a lot, Mike.
Seeing the pictures from here on Earth, it's really like being there. So thanks a lot, Mike.
Robert, it is our pleasure, the Expedition 14 crew of the International Space Station Alpha, as well as the NASA team, to participate in this first ever HTTV event. We had a great time showing you kind of what it is that we do up here day to day, and we look forward to more of the same in the future.